Hello everyone, welcome back to Java for Dummies. Today we are going to cover Java class types, all of them. We will look at what each class type is, what it can do and cannot do. And we will see a real code example for every single one. We will look also how these class types work together, like what happens when an abstract class extends another abstract class or when an abstract class implements an interface. By the end of this video, you will have a very clear picture of all class types in Java. Okay, let's go. The first one is the concrete class. This is the most basic and most common class in Java. We write it using the keyword class, nothing special in front of it. The most important thing about a concrete class is that you can create an object from it directly using the word new. It can have a field, a constructor, and methods. Methods can be regular or static, can extend one class and implement as many interfaces as we want. One rule to remember, if a concrete class extends an abstract class, it must implement all the abstract methods. We will see that in more detail later. Look at the code on the right. We have a class called dog. It has two fields, name and age. It has a constructor to set them. It has a method called bark that print a message. And it has a static method called info. At the bottom, we create a dog object using new, pass in the name Rex and age tree and call bark. Simple and clean. This is what we write every day in Java. Now the abstract class. This one is a little different. You write it using the words abstract class. The big difference is we cannot create an object from an abstract class directly. We must first make a subclass and create the object from that. An abstract class can have abstract methods. These are methods with no body, no code inside them. The subclass must fill them in. It can also have normal methods that are already done. The subclass just use them. Look at the code. We have an abstract class called animal. It has two abstract methods, make sound and get type. Nobody, just the name. It also has a normal method called breathe, which already works. Then we write a concrete class called cat that extends animal. Cat must implement both abstract methods make sound and get type. It fills them in with its own code. At the bottom, we try to create an animal object that gives an error, but creating a cat works fine. Cat can call, make sound, and also call breathe, which it got from animal. Next is interface. Think of an interface as a list of rules or a contract. You write it using a keyword interface. You cannot create an object from an interface. A class follows an interface using the word implements. The big thing here is a class can implement many interfaces at the same time. By default, all methods in an interface are empty abstract. But since Java 8, we can also have default methods. These have a body and can be used without overriding. You can also have static methods. Since Java 9, private methods are also allowed inside interfaces. All fields in an interface are always public, static, and final. Look at the code. We have an interface called flyable. It has two abstract methods, fly and land. It has a default method called glide, which already has a body. It has a static method called describe. Then we write a class bird that implements flyable. Birds must provide fly and land, but glide is already done. Bird just inherits it. At the bottom, we create a bird, call fly, then call glide, both work. Now the final class. This one is simple. You write it using the words final class. A final class is a locked class. We can create an object from it normally using new, but nobody can extend it. No subclass is allowed. If we try, Java gives a compile error straight away. It can still extend another class and implement interfaces itself. All its methods are also final automatically. Real example in Java, string is final, integer is final, the math class is final. Look at the code. We have a final class called circle. It has a radius field, a constructor and two methods, area and perimeter. At the bottom, we show how happens if we try to extend circle. Java gives an error. But creating a circle object works fine. We create one with radius 5, call area and get 78.53 and call perimeter and get 31.41. Now we go inside the class. The static nested class is a class that lives inside another class and it is marked as static. Because it is static, it doesn't hold any connection to the outer class. It doesn't need an outer class object to be created. You just write new outer dot nested and you are done. It can only access the static member of the outer class, not the regular instance members. It is commonly used to group helper classes together and in patterns like builder or factory. Look at the code. We have an outer class with a static field called brand and a regular field called model. Inside, we have a static nested class called nested. Its, its show method can access brand because that is static, but it cannot access model. We also have another nested class called builder as an example. At the bottom, we create the nested object without any outer object, just new outer dot nested. The inner class also lives inside another class, but this one is not static. This is the key difference. Because it is not static, it is connected to the outer class. It holds a reference to the outer class automatically. This means it can see and use all the fields and methods of the outer class, even private ones. To create an inner class object, we first need an outer class object. The syntax is outer object dot new inner. Look at the code. We have a class called engine with two fields, horsepower and type. Inside engine, we have two inner classes, piston and valve. Piston's fire method directly uses type and horsepower from the outer class. No special code needed. At the bottom, we first create an engine object, then use it to create a piston. When we call fire, it prints the engine type and power. Anonymous class. The anonymous class has no name. We create it and use it right there in the same spot all in one go. It is used when we need a class just one time and do not want to write a full separate class for it. It can extend a class or implement one interface. It cannot have a constructor. Any variable it uses from outside must be effectively final, meaning its value does not change. Today, anonymous classes are mostly replaced by lambda expressions, but it is still important to know them. Look at the code. We have an interface called greeting with one method called greet. Then we create two anonymous classes, formal and casual, both implementing greeting in a different way. No class name anywhere. Just new greeting, open curly brackets, write the method, close brackets. At the bottom, we also show the same thing done with the lambda, much shorter. Java 8 and above, we can do this with one line. Enum is used when you have a fixed list of values that never change, like days of the week or planets or directions. You write it using the keyword enum. You cannot create an enum object using new. Each constance is already a single object, a singleton. An enum cannot extend another class because it already extends java.lang.enum automatically. But it can implement interfaces and it can have fields, methods, and a constructor. Look at the code. We have a planet Enum with three planets, Mercury, Venus, Earth. Each planet has two values, mass and radius. The constructor takes these two values. There is a method called surface gravity that calculates gravity using those values. At the bottom, we get the Earth constant called surface gravity and it returns 9.80. We can also get all planet using values or get one specific planet using value of. Sealed class is a newer feature added in Java 17. We write it using the word sealed class and then the word permits followed by a list of class names that are allowed to extend it. Only one class in that list can extend the sealed class. Nobody else. Every class in that list must be one of three things: final, meaning nobody extend it further, or sealed, meaning it control its own subclasses, or non-sealed, meaning it opens up and anyone can extend it. Sealed classes work very well with pattern matching in Java 21. Look at the code. We have a sealed class called shape that permits only circle, rectangle, and triangle. Circle and rectangle are final locked. Triangle is non-sealed and open. Below that, we have a switch statement that handles each type. Because shape is sealed, Java knows all possible types and makes sure we handle all of them. Very safe and very clean. Record is another newer feature added in Java 16. We write it using the keyword record followed by the name and then the fields inside round brackets. A record is designed purely for holding data. All fields are private and final automatically, and Java automatically generates the constructor, the getters equal hash code, and toString. We do not write any of that ourselves. That saves a lots of code. A record cannot extend another class. It already extends record automatically. But it can implement interfaces and we can add our own custom methods. Looking at the code, we have a record called person with just two fields, name and age. One line. Java gives us everything. We create a person, call name and age like methods, call to string and it prints nicely. Call equals and it works correctly. Below that we have a point record that implements an interface called printable. It provides the print method and then we call it. It prints the coordinates. Now let's look at how class types work together. This is a very important slide. What happens when an abstract class extends another abstract class? The rule is simple. It does not have to implement the abstract methods. It can just leave them open and pass them down to the next class. Look at the left side. We have a class called vehicle with two abstract methods, start and stop, and one normal method called freefull. Then we have abstract car which extends vehicle. Abstract car does not implement start or stop. It just adds a new abstract method called open door and a new normal method called honk. Now look at the right side. Sedan is the first concrete class in this chain. Sedan must implement all three open methods start, stop, and open door. If it misses even one, Java gives a compile error. But refuel and hunt are already done. Sedan just inherits them for free. So remember, abstract classes can keep passing the work down, but the first concrete class must do all of it. What happens when an abstract class implements an interface? The rule is the abstract class can implement some, all, or none of the interface methods. Whatever it does not implement, the concrete subclass must handle. Look at the left side. We have an interface called drawable with three methods: draw, resize, and color. Then we have an abstract class called shape that implements drawable. Shape implements resize and color. Those are done. But shape does not implement draw, it leaves that open. Now look at the right side. Circle extends shape. Because draw was left open, circle must implement draw. But resize and color are already done by shape. Circle just inherit them. At the bottom, if you forget to implement draw in circle and circle is not abstract, Java gives a compile error. Always check what is still open. This pattern is very common in real Java code. Abstract class handle the shared work and subclass handle only what is different. Interfaces can also extend other interfaces, and an interface can extend more than one interface at the same time. The rule is when an interface extends another interface, it does not implement anything. It just takes everything from the parent interface and adds more on top. The class that eventually implements it must implement everything from the whole chain. Look at the left side. We have two interfaces, readable with a read method and writable with a write method. Then we create a combined interface called DataStream that extends both. DataStream also adds two more methods, seek and close. No implementation anywhere in the interface. Look at the right side. FileStream implements DataStream and must implement all four methods read, write, seek, and close. At the bottom, we create a file stream and call all four methods. We can also skip the combined interface and just write implements readable, writable directly on the class. Same result. Here is the full picture in one table. Concrete extends concrete. We inherit everything. Overrides are optional. Concrete extends abstract. We must implement all abstract methods. Concrete implements interfaces. We must implement all interface methods. Abstract extends abstract. We can pass everything down. Nothing to implement now. Abstract implement interfaces. We can implement some, all or none. Whatever is left, the subclass handles. Interface extends interface. No implementation needed. Can extend multiple. Can add new methods. Sealed permits subclass. The subclass must be final, sealed, or non-sealed. Record implements interfaces. Must implement all interface methods. Enum implements interfaces. Must implement all interfaces methods inside each constant. Keep this slide handy. It covers every possible combination. Now the full comparison table is here. All 10 classes types side by side compared here. I recommend you to have a pause in the video and look detail this one. For a quick recap, you can follow this slide. It's bring it all together. Take a pause and go through the slide. That is all 10 Java class types. I hope this video made it simple and clear. If it helped you, please like and subscribe to Java for Dummies. Drop a comment if you have any questions. See you in the next video.